Hello, everybody, and welcome back to another funky episode of BEDMAS. Hope you're all having a fantastic day. I'm having a decent day so far. It's early in the morning, and I figured, hey, what better way to start the day than to record a little BEDMAS for you. So, in the last video, we discussed order of operations, a super important topic in math that's going to open the doors to being able to do a lot of other stuff. That's kind of like the exciting part about doing these math videos, is that it's just that with every topic you learn, you unlock access to several more topics, right? So it just kind of keeps expanding. But we talked about order of operations and why they're important. Essentially, it gives us a way to do math consistently. How do I make sure that I'm doing the same math as someone else is doing? And the way we ensure that is to make sure that we have conventions. So that's to make sure we're doing things such as, for example, making sure we do multiplication and addition in the same order as the next guy. Alright, so today we're going to get comfortable with those topics. I've got 5 questions for you that should be flashing on the screen now. So as always, give those a shot, and once you've given them a good honest effort, you can watch the remainder of this video with me, and we will go through the answers. Question 1. Alright, so question 1 says evaluate the following expressions. So this is just where we're just full on practicing the order of operations. So the acronym that I taught was BEDMAS, either that or PEMDAS. It's kind of up to you. Technically, PEMDAS is a little better because these round braces are called parentheses, not brackets technically. But again, since this is really common, and this is the way I was taught, this is another way to kind of reference it. So we got to start by evaluating 1 minus 3 times 6 plus 6 minus 2 times 2 to the power of 4. So the first thing we concentrate on is going to be the parentheses, right? So then we look inside of the parentheses. And inside of the parentheses, we've got a subtraction and a multiplication, but just following our acronym, we do the multiplication first. So 2 times 2, that is 4. Alright, so we still got our parentheses here, so we're going to have to evaluate this. But since that's the last thing we're going to be evaluating inside, we can now drop the parentheses once we do that. And we are going to get 2 to the power of 4. Alright, now we can evaluate this 2 to the power of 4, right? Because exponents come before anything else now. So 2 to the power of 4, that's 2 times 2 times 2 times 2, right? Just 2 multiplying by itself 4 times. If you do that, you'll get 16. Now we can do this multiplication step here. So 3 times 6, that's 18. So we get 1 minus 18 plus 16. And now with subtraction and addition, because the order doesn't really matter, we can just evaluate these together. And the convention is always just to kind of go left to right. So if we do 1 minus 18, we get negative 17. And if we add the 16, we get negative 1. So negative 1 is looking like the answer for us. So in this situation, we once again have parentheses, so we got to look inside of there first. Inside of there, we have division and subtraction. So division comes first, so we're going to evaluate this division statement. So now we have to recall, okay, how do we divide some fractions? Well, that's going to be the same as multiplying by the reciprocal, right? So this becomes 2/3 plus 4/7 times the reciprocal, which is 14/3, and we're subtracting a half. Okay, so we didn't really evaluate this yet. We still have to do that. We just put it into an equivalent form that's going to make it easier for us to evaluate. 4 times 14, that is going to be 56. So we get 56. 7 times 3 is 21. And we're subtracting a half. Now, question for you. Do you think the brackets were necessary here? I don't think they were, because ultimately we're still going to have to do this division first, regardless if we had the parentheses or not, right? And we also see here that when we've evaluated it, we really just have a plus and a minus, right? So these parentheses aren't really doing anything for us because we're going to be evaluating this division statement first. The parentheses weren't really necessary. If I do the subtraction first and then I do the addition, that's going to be the same as if I did the addition first and then the subtraction. So we can drop the parentheses if we want. All right, so 56 over 21, those are both divisible by 7. So this is going to simplify down into let's see, 8/3. All right, so this is nice. We already have a common denominator here. So 2/3 plus 8/3, that's 10/3. And then to subtract off this half, we need to make our common denominator, which is going to be 6. So multiplying these both by 2 and multiplying these both by 3, we get 20 over 6 minus 3 over 6, which leaves us with 17 over 6. All right, part C, we have 1 over 6, and then again, when it's right next up with the parentheses, is the same as 1/6 times that. So we have 1/6 times 2 plus 3 squared times 18 over 5. All right, so let's see what we get. Well, we have to do what's in the parentheses first, right? So we're focusing on this statement here. And now that we're focusing on this piece, we have to do order of operations again, which is going to entail that we basically focus on the exponent next, right? Because exponent comes before the multiplication or the addition. So we're now focusing on this 3 squared. And 3 squared, that's 3 times 3, which is 9. All right, so once again, we're looking at the parentheses statement, and we're doing the multiplication inside, since that comes before addition. 9 times 18, that is going to be 162, I believe, and all of that over 5. And now we can add these two now, right? Although this is multiplication out here, because we have parentheses, that's prioritizing this addition statement first. So we want to evaluate this addition. So 2 plus 162 over 5, we're going to need to make a common denominator. So 2 is the same as 2 over 1, and the common denominator is just going to be 5. So if we multiply the numerator and denominator here by 5, we are going to be able to achieve that. So we end up getting 1 over 6 times 10 over 5 plus 162 over 5, which becomes 1 over 6 times 172 over 5. And now that we've evaluated everything in the parentheses, we can drop it, and we have this statement here. So then multiplying the numerators and denominators, we get 172 over 30. And these can both be divided by 2, which will give us 86 over 15. And that should be as simplified as it gets. Okay, so once again, let's just focus on the parentheses here. But actually inside the parentheses, we have another set of parentheses. So we actually have to start by focusing on the inside there. And inside here we have multiplication and subtraction. So we evaluate the multiplication first. So this is the first thing we're going to be looking at in this whole statement here. So we got 3 minus negative 2 plus 5 minus 2 times 6 times 3 is 18. So that's what we evaluate first. Everything else just stays the same. Now, there's another thing that we can note here. Do you think that if I evaluated this 3 minus negative 2 over here, would that affect anything on the inside over here? The answer is no, because they're separated by addition. Since addition is going to be basically the last thing that we evaluate, if I evaluate this over here separately from this over here, since they're not connected by anything else, that should still be fine. So as you do order of operations, you'll find that you can actually start doing maybe several operations at once. The more you do it, the more you'll get a feel for it. But since this right here is completely separate from this over here, they're just being added. That's the only way they're being combined. It's not through multiplication or anything. Then we can actually evaluate them separately. And we could have actually done this a couple other times. For example, in part A, we started by looking at everything inside of these parentheses, which is fine. But since it's separated by addition from over here, we actually could have also started evaluating this piece here, right? We could have done the 3 times 6 and gotten 18, and then done 1 minus that. And we could have been doing that at the same time as we were evaluating this statement over here. So kind of as you go, you might start to get a bit more of an intuition for how we can do these a little faster. So we can do this 3 minus negative 2, and remember that subtracting a negative is the same as addition, right? So this becomes negative 3 plus 2. Right, so we've simplified that a little bit, and now we can focus on this statement again. So we still have this part on the inside with the parentheses here. So we should be focusing on 18 minus a third. So this is the same as 18 over 1, and making a common denominator of a 3. Let's see what that gives us. So 18 times 3 is 54. All right, so we can keep evaluating this, but again, we can finish evaluating over here. Negative 3 plus 2 is negative 1. All right, so now that's all nice and simplified, and we'll be ready to go for when we've completed this part here. So we've got 5 minus 2, and then 54 thirds minus 1/3 is 53 over 3. And we don't really need the parentheses anymore, but we can write it to show we're doing the 2 times that. All right, so what's 2 times 53 over 3? Well, this is 2 over 1 times 53 over 3. Multiplying the numerators and denominators, we end up getting 106 over 3. All right, and once again, we are going to want to make a common denominator. So the common denominator is going to be 3 here. So I'm going to multiply this 5 over 1 by 3 in the numerator and denominator, and that's going to give me 15 over 3 minus 106 over 3. And one thing to notice is I dropped the parentheses here because we just have addition and subtraction, so we're just evaluating this from left to right. So 15 thirds minus 106 over 3, that is going to be, let's see here, that's going to be negative 91 over 3. And once again, to make a common denominator, we make this negative 1 into a negative 1 over 1. And remember, adding a negative is the same as subtraction, so I converted this plus negative 91 over 3 into minus negative 91 over 3, but we end up getting negative 94 over 3. Alright, so a little bit hairy, but it's good to be practicing with kind of complex fractions. We've been doing a ton of things with fractions, so this is the perfect place to really be practicing that. For some extra practice, just make an expression with various numbers, choose both whole numbers and fractions, as I've done here, and use various combinations of operations and parentheses. So basically just kind of slap them all together and see what it evaluates to. Use the order of operations, and just keep doing this till you get a good feel for it. You can use a calculator to verify that your answer is correct.
Question 2.
All right, question 2 asks us to evaluate these three expressions, and they look very similar, right? They have a 2 to the power of 2 to the power of 3, just with different parentheses in different spots. So let's start with this first one, 2 to the power of 2 to the power of 3. So you might have never seen this before where we have an exponent to another exponent. It's kind of weird, but we know that we can evaluate this by using order of operations. So let's see what this evaluates to. So there's no parentheses, but we have exponents. So we have to focus on the exponent. So where's the exponent? The exponent is right here, right? This is like our first exponent. So we have to evaluate this 2 to the power of 3 first, actually, because that's what's in the exponent. So 2 to the power of 3, that's 2 times 2 times 2, that's 8. So what we end up getting is 2 to the power of 8 here. All right. So again, because we're doing the exponent first, we have to evaluate what's in the exponent, and that's 2 to the power of 3. All right, so now that we have that, we can do 2 to the power of 8, and that's just 2 times itself 8 times. So we could just do that by doubling the 2 each time. So we have 2, 4, 8, 16, 32, 64. I'm just multiplying it by 2 every step, right, so that we can get to 2 to the power of 8. 64 times 2 is 128. 128 times 2 is 256. 256 times 2, that is 512. And let's see if we've done 8 yet. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I did one too many. So 256 is going to be 2 to the power of 8. So that is our answer. Let's look at part B and see how it's different. Here we have 2 squared to the power of 3. So because we have parentheses, we're going to actually be evaluating this 2 squared piece first, and then adding the power of 3 after. So 2 squared, that is 4. And then adding our power of 3, this becomes 4 to the power of 3, or 4 times 4 times 4. And that, you'll find, is going to be 64. So we get two very different answers because we're evaluating kind of it differently. Here, we have to evaluate everything in the exponent first by the order of operations. Here, we're using parentheses to say we want to evaluate this part first, and then add our new exponent after. So we get a different thing. For part C here, we have 2 to the power of 2 to the power of 3. Now, this is telling us we need to evaluate this 2 to the power of 3 first, because that's where the parentheses are. But this is actually kind of unnecessary, because we knew from part A that we had to do that anyways if we were following order of operations. So this is literally just the same thing as what we had in part A, which evaluated to 256. So we get the same answer in part A and part C, just with two different ways of expressing it, this one being slightly less efficient, but maybe a little more obvious that that's what we're actually evaluating, is the exponent first.
Question 3.
So question 3, just another evaluation, just maybe a little trickier. And there's one too many parentheses here, so should get rid of that. So order of operations, we'll start with parentheses. Now, that means we're going to be starting with this part down here. However, since we basically have this whole expression divided by this whole expression, we know that kind of implicitly, this means that we have the numerator all being grouped together. We could imagine there being parentheses, divided by the denominator all being grouped together. We could imagine there being a bigger pair of parentheses out here. But what this ultimately means for us is that we can basically plug away at both the numerator and the denominator at the same time. So with my next step, I don't have to just work on these parentheses down here. I can also work on some things in the numerator kind of simultaneously. So in the numerator, we are going to be looking at the exponent first. And the exponent is actually this kind of complex expression here. So we're going to be looking at evaluating that first. And within that expression, we're going to be doing the multiplication first, right? So we get 4 plus 2 to the power of 2 plus, and 3 times 2 is 6, minus 4. And then the denominator, we can focus on this parentheses here. Well, 10 divided by 2 is 5, right? So we get 3 minus 2 plus 5 like that. All right, so now we have 4 plus 2 to the power of 2 plus 6 minus 4. So we can still evaluate this power now, and we can just add and subtract all these, right? 2 plus 6 is 8, subtract 4, we get 4. So we get 4 plus 2 to the power of 4. And then the denominator, we have 3 minus 2 plus 5. So would it matter if I didn't have these parentheses here, since we only have addition and subtraction? The answer in this case is actually yes, and let me show you why. So if I did something like 3 minus 2 plus 5, so no parentheses, I do 3 minus 2, which is 1, and I add 5, and I get 6. Whereas if I did 3 minus 2 plus 5, well, then what I get is 3, and I do parentheses first, so I get 7. 3 minus 7 is negative 4. So these give me two different answers, right? And this is actually very analogous with what we saw with the division and the multiplication problem at the end of the last video, where if we did something like 6 divided by 3 times 2. Well, 6 divided by 3 is 2, and then multiplying by 2, we get 4. Whereas if I had parentheses here, I do 3 times 2 first, which gives me 6, and 6 divided by 6 is 1, so they're not the same thing, right? So we need to make sure that we are respecting these parentheses here and doing them first. So we have 3 minus 2 plus 5, which is minus 7. So in the numerator, we get 4 plus 2 to the power of 4. 2 to the power of 4 is 16. And 3 minus 7 is negative 4. 4 plus 16 is 20. 20 over negative 4, that's going to give us negative 5.
Question 4.
All right, so question 4 gives this big complex expression, but we don't have to evaluate it. All it says is just identify the unnecessary pairs of parentheses. All right, so for this one, let's just kind of go through in order and see what happens. So we have a 1 here. Now, a 1, it doesn't need to be in parentheses, right? It's just a single number. So this one is not necessary. However, for the next one, it actually is necessary, because when we're adding a negative, if we didn't have this brackets here, it might look kind of weird if it looks like plus and then subtract, if we interpret this minus as a subtraction. So by putting in parentheses, it just makes it more clear that we're adding a negative number here, and we're not somehow adding and subtracting one at the same time. So this negative symbol is meant to indicate that we're looking at a negative number. It's the additive inverse of 1, right? So this parentheses is a bit more necessary than this one over here, which it wasn't necessary. And then we're doing plus 8 minus 1. Is brackets really necessary here? And the answer is no, because it doesn't matter if we add the 8 first and then subtract the 1, or if we do 8 minus 1 and get 7, and we add that afterwards. Basically, if we didn't have parentheses, the order of operations would give us the exact same result. So that is unnecessary. Over here, however, this is necessary, and we just kind of discussed this in question 3. When you're subtracting a addition or a subtraction statement here, that's basically saying you're taking this entire thing here and you're subtracting it off. But if we didn't have this statement, we're actually only subtracting off the 3, right? We're not subtracting off whatever this all evaluates to. So this is actually necessary to keep those parentheses. And if you need some more convincing, just try and do it on the side. Try and do something like 5 minus, and then in parentheses, 3 minus 2, versus 5 minus 3 minus 2 without parentheses, and you're going to see you get different results. Over here, we kind of do need the parentheses because we're doing 5 times an addition statement, and if we want to evaluate the addition before the multiplication, which these parentheses are indicating, then the only way we can do that is by ensuring that we use these parentheses. So these are necessary. Over here, we're subtracting 2 times 3. This is not going to be necessary because If I do 2 times 3, that's going to give me 6, and then I'm subtracting it off. Great. However, if I didn't have the parentheses here, I'm still doing the order of operations where my multiplication comes first, right? So multiplication is going to come before the subtraction either way. So this is unnecessary. All right, for this next set of parentheses here, we've got 1 minus 2 times 3 over 6. However, since this is inside of a fraction, the numerator is always going to be kind of evaluated, and the denominator is going to be evaluated before we divide it. We talked about how there's essentially an implicit pair of parentheses in the numerator and the denominator inside of a fraction. And because that's already essentially implicitly there, we don't need to explicitly write it with parentheses. So this is also an unnecessary pair of parentheses. All right, and then lastly over here, we have 3 times 2 minus 1 divided by 5. So the interior pair of parentheses is definitely necessary, because if we were respecting order of operations, this division would happen before the subtraction, so we'd be doing 3 times 2, we'd be doing 1 divided by 5, and we'd be subtracting those two results if the parentheses weren't there. However, we want to prioritize doing the subtraction here before we do this division, so that's definitely a necessary pair. However, since this is an overall division statement in here, that's going to happen before we do the subtraction, regardless if this outside pair of parentheses is there or not. So this outside pair of parentheses is actually going to be not necessary. All right, so I hope that made sense. And for extra practice, if you want, evaluate this expression. It's a bit hairy, but you can do it.
Question 5.
All right, so question 5, this is an interesting one. So there's another operation called tetration, and tetration essentially compacts exponentiation. So for example, 4, and then we use this double up arrow to indicate we're doing the tetration. So 4 to the tetration of 5, and then we just have 5 4s here, right? But it's all exponents. So we know that something like 4 to the power of 5, that is just 4 times itself 5 times. And we know that 4 times 5, that is 4 plus itself 5 times. This tetration is essentially just taking that idea a step further, where we do 4 tetration 5. That's just 4 to the power of itself 5 times. It's just kind of a natural extension of this pattern we've already been using. So for part A, it says, if we were to add tetration to the order of operations, where would make the most sense to add it? Okay, so for this, we need to really think back to why we did the order of operations in the way we did it. And in particular, we talked about how we saw that exponentiation came before multiplication, since exponentiation was essentially compacted multiplication. And multiplication came before addition, since multiplication was essentially compacted addition. So since tetration is essentially compacted exponentiation, it probably makes sense for us to put tetration before exponentiation. So we probably want to put tetration between the B and the E. And it still has to come after the B so that we can still prioritize things with parentheses or with brackets, right? So we would expect tetration to come there. And then it says, using this new order of operations, let's actually evaluate a statement that has tetration involved. So we have 3 squared times 2, and then we have tetration 3. Using our new order of operations, we're going to evaluate the tetration statement first. So 2 tetration 3, that's the same thing as 2 to the power of itself 3 times, right? And we know how to evaluate something like this, and we actually talked about this in an earlier question. So we start by looking at the exponent. So 2 squared, that is 4. So this becomes 2 to the power of 4, and 2 to the power of 4 you can evaluate, that's going to be 16. So this expression here becomes 3 squared times 16. And now we have an exponent and we have a multiplication, so we'll evaluate the exponent first. 3 squared, that's 3 times 3, which gives us 9. And lastly, 9 times 16, that is going to be 144.
Concluding thoughts.
All right, so that's going to do it for today's episode. We got a lot of good practice by solving some fairly tricky problems, or fairly hairy problems, for order of operations, but this is where all of this fraction practice that we've been doing over the last dozens and dozens of videos is really going to come in handy. And we also talked about some other interesting things, like where are parentheses necessary, what happens when we start defining new operations, where do we put that into the order of operations? And that is actually going to be very relevant, because math gets more complicated and we're going to be looking at more and new types of operations. So it's going to be necessary to consider, okay, where do we actually put them inside the order of operations? And a tetration is just kind of one nice example of that. So that's it for today's video. You have a good one, you stay groovy, and I'm going to see you in that next video.
BEDMAS.